In part 3, we introduce ER diagram representation. Please take a moment to read the learning objectives for this video. Let us now learn how the ER model is represented by means of an ER diagram. Any object, for example, entities, attributes of an entity, relationship sets, and attributes of relationship sets can be represented with the help of the ER diagram. The entity relationship model is a representation of the conceptual database as viewed from the end-user perspective. There are various notations, for example, the chance notation and the crow's foot notation. Entity is a person, place, thing, or event about which data will be collected and stored. For example, in school database, a student is considered as an entity. An entity is an object of interest to the end user. An entity corresponds to a table. In all notations, an entity is represented by a rectangle. Attributes are characteristics of entities and are usually represented as fields of the table at the implementation level. Every attribute is defined by the set of values called the main. For example, student can have various attributes like name, age, class, and etc. A required attribute is an attribute that must have a value and cannot be left empty. The two bold-faced attributes in the crow's foot notation indicate that the data entry is required. An optional attribute is an attribute that does not require a value and can be left empty. In the chain notation, attributes are represented as ovals, each containing the name of the attribute it represents. In the crow's foot notation, the attributes are written in the attribute box below the entry rectangle. There are several types of the attributes, which are the simple, composite, derived, single value, and multi-value. Attributes are classified as simple or composite. The composite attribute is an attribute that can be further subdivided to additional attributes. For example, the attribute phone number can be subdivided into the area code and exchange number, and the name can be subdivided into last name and first name. A single-valued attribute is an attribute that can have only one value. Multi-valued attributes are attributes that can have many values. For example, a person may have several college degrees. In a household, may have several phone numbers. In the chain notation, multi-valued attributes are shown by a double line connected to the attribute to the entity. The crow's foot notation does not identify multi-valued attributes. A derived attribute or computed attribute is an attribute whose value is calculated from other attributes. The derived attribute need not to be physically stored in the database. The association among entities is called a relationship. For example, an employee works at the department. A student enrolls in a course. Works and enrolls are called relationships. A relationship between entities always operates in both directions. To define the relationship between the entities name, entity relationships may be classified as one-to-one, one-to-many, or many-to-many. Cardinality expresses the minimum and maximum number of tuples associated with one tuple of the related entity. One-to-one is when one instance of an entity is associated with the relationship. The following image reflects that only one instance of each entity should be associated with the relationship. For example, a rector can manage one university. A university can be managed only by one rector. One department has one head. One key can open only one lock. One-to-many is when more than one instance of an entity is associated with a relationship. The following image reflects that only one instance of an entity on the left and more than one instance of an entity on the right can be associated with a relationship. For example, one department has many professors. A bank client can own many credit cards. A credit card can be associated with only one bank client. Many-to-many is when one instance of an entity on the left and more than one instance of an entity on the right can be associated with a relationship. For example, many students can enroll to one or many classes. Class can be taken by one or many students. Depending on the rules of the university, the class might be optional or mandatory. Total participation is when each entity in the entity set occurs in at least one relationship in that relationship set. In the Krauss-Foot notation, an optional relationship is shown by drawing a small circle on the side of the optional entity. Here you can see the differences in Chen and Krauss-Foot notations. The ER model has the power of expressing database entities in a conceptual hierarchical manner. As the hierarchy goes up, it generalizes the view of entities, and as it goes deep in the hierarchy, it gives us the detail of every entity included. Going up in the structure is called generalization, where entities are clubbed together to represent a more generalized view. For example, a particular student named Mira can be generalized along with the students. The entity shall be a student, and further, the student is a person. Specialization is the opposite of generalization. In specialization, a group of entities is divided into subgroups based on their characteristics. Inheritance is an important feature of generalization and specialization. It allows lower-level entities to inherit the attributes of higher-level entities. To sum up, entity is a person, place, thing, or event about which data will be collected and stored. Attributes are the properties of entities. Relationships are the logical association among entities. The process of generalizing entities, where the generalized entities contain the properties of all generalized entities, is called generalization. In specialization, a group of entities is divided into subgroups based on their characteristics. Inheritance allows lower-level entities to inherit the attributes of higher-level entities.